Commodity Channel Index is a bounded oscillator that measures a stock's price variation from its statistical mean. 20 days and constant factor are commonly used to make sure most values fall within bands. For full reference, I recommend that you read Donald Lambert, Commodity Channel Index, Tools for Trading Cyclic Trends, published by Commodities Magazine, now Futures Magazine in 1980. Its calculation has the following steps. A. Typical price calculation. Typical price is equal to high plus low plus close prices divided by 3. B. Typical price smoothing calculation. For this, we have a 20-day simple moving average of typical price, which is equal to the sum of those 20 days of typical prices divided by 20. C. Mean absolute deviation calculation. Mean absolute deviation is equal to the sum of those 20 differences of the absolute value of the 20-day simple moving average of typical prices minus the typical price divided by 20. D. Commodity Channel Index calculation. Commodity Channel Index for those 20 days and that constant factor of 0.015 is equal to the typical price minus the SMA 20 or 20-day simple moving average of typical price divided by the constant factor 0.015 multiplied by the mean absolute deviation. Great. So let's go back into our Python PyCharm IDE so that we can study Commodity Channel Index with greater detail. Excellent. So here we are back within our Python PyCharm IDE. In this lecture, we'll be working within Commodity Channel Index code file. If you have any questions about its setup, please go back to section 1, Stock Technical Analysis Data lecture, where all of that explained with greater detail. So as these are meant to be standalone type of files, first we import our packages, NumPy as MP, Pandas as PD, Matplotlib as PLT, Talib as TA. Then we proceed to do our data reading by default by creating SPY data frame, which is equal to pd pandas.read_csv, the path to our data, which is that directory data created previously, and the corresponding text file, which includes CSV or comma separated values, index column as date, and we parse those dates as true. Then we do our technical indicator calculation. Here we have the new column created, SPY CCI or Commodity Channel Index, and we use Talib's CCI with capitals function. Then we're going to provide MP, NumPy, as array, high, low, and close prices, and right here we have the time period of 20 days. Again, these are the characteristics commonly used for this calculation, but they can be modified according to your needs. Then we have the corresponding technical indicator chart. Fig1, comma, AX or axis equals PLT.subplots, two of them which share X as true. Then we have in the first of our charts at position 0, we plot close prices with their legend located at the upper left, and then in the lower chart at position 1, we plot our Commodity Channel Index colored in green to differentiate from the prices above, its legend located at the upper left. Then we add the superior title for all of the subplots, which is SPY close prices and Commodity Channel Index CCI for those 20 days and the constant factor of 0.015, and then we show the chart. So let's proceed to run the code by clicking the right button on the mouse and scrolling down into Run Commodity Channel Index. Excellent. So here we have our corresponding chart. So let's make it a full screen manually because of the screencast. There we are, up to here, and then all the way into the bottom. Excellent. So here we have our chart. SPY close prices and Commodity Channel Index CCI, 20 days and constant factor of 0.015. Then we have at the top our corresponding close prices. At the bottom we have the Commodity Channel Index. And here we have those two plots sharing the horizontal axis, which are those dates, from the beginning of 2016 to the beginning of 2017. We'll study later on how this corresponding oscillator generates the corresponding trading signals. Excellent. So we're going to close that chart, also this one, and the last one. Excellent. So now that we've finished studying our commodity channel index, it's time to continue with the next of our leading type of technical indicators, which is our moving averages convergence divergence, commonly known as MACD, and that is going to be our following objective.